Good afternoon, student. Welcome back to Mr. Chen's masterclass for pre-cal. So we're talking about the polar equations. So this one is sections 8.2 from the James Stewart textbook. It's all about making a graph of the polar equation. So we just want to divide this section into two parts. So the first half today, so we're talking about the circle and also the line graph from the polar equation. So anytime that I deal with the structure like r equals a, where a it's a real number, so generate a circle center at the origin. And r equals a cosine of theta, r equals a sine of theta. So notice that origin, it's just the pole. And where a it's the diameter of the circle, so generate a circle along the x-axis or the y-axis. And the following, the circle is shifted along x or y, so r theta. So that equals a cosine theta plus b sine theta. So this one is just like a general concept, like the easy way to recognize the circle equation from the polar. But the best way to do it is to find out the conversion. So from polar to rectangular, so we can use the conic sections to make the equation of a circle. So one thing that you notice for the equation of a circle is always consider x minus h quantity square plus y minus k quantity square equals r square. So imagine that we do have a unit circle. So the center is always started at the origin. Okay, like this. So r. So let's say that the point here, x comma y. Here's theta. Okay, so that just related with what we did in conic section. So now the way to convert those polar equation. Okay, so let's go back to the template. Okay, so let me just pull this out. Okay, so let's say we do have the polar equation. So the first one, r equals 2 sine theta. So you might be wondering the way to convert it back to the rectangular form. So what we can do, we can start it off with multiplying r on both sides. So r times r. So 2 sine of theta times r. So one thing that we notice, r times r, that's r squared. So 2 times r times sine of theta. So 2r sine theta. And what we notice from the previous sections, the conversion, r sine theta is just like y replacement. R squared is just like x squared plus y squared. And then from here, we want to convert it back to the equation of a circle. So x squared, bring everything all together to one side. So plus y squared minus 2y. And then the right hand side, it just considers 0. And now we want to complete the square for this. So y squared minus 2y plus 1. So add 1 on both sides. Again, b over 2 quantity square. So negative 2 over 2 quantity square. And then x squared, just leave it by itself. So the trinomial, the y group term, so perfect square, so it's y minus 1 quantity square, so that equals 1. So this one's the equation of a circle, so the center started at 0 and 1. So 0, 1, which is all the way up here. And then the radius, which is 1. So 1 unit to the right. And 1 unit's up. 1 unit down. Okay, so the equation of a circle. 1 unit to the left, 1 unit to the right. And then basically just connect them. And then for B, that's quite similar. And also C, the origin started at 0, 0, because that's showing x squared plus y squared. Square root of that is what, 3. So the radius for this circle, for C, so x squared plus y squared equals 9. If you try to square both sides. Okay, so that one's relatively easy. And then for B, so r multiplied by r both sides, so negative 3r cosine theta. R squared equals negative 3x. Again, this one, rewrite it, x squared plus y squared minus 3x. Regroup them, x squared minus 3x. Complete the square, so negative 3 over 2 quantity square, 9 over 4. Okay, so add that 9 over 4 both sides. So x minus 3 over 2 quantity squared plus y squared. So that equals 3 over 2 quantity squared. So the center is right at 3/2 and 0, and the radius is 3/2. So now, what about for D? Okay, so check it out for D. So that one looks a little bit complicated. Okay, let's do this. Okay, so for D, so what we got here, so multiplied by r both sides, so we do have r squared equals 4r sine theta plus 4r cosine theta. Again, rewrite it, so 4y plus 4x, and then r squared just like x squared plus y squared. Bring everything together to one side, regroup. Same thing happened to y group here, so bring everything together. Complete the square for this, so f4, f4. So again, b over 2 quantity square. So negative 4 over 2 quantity square. So x minus 2 quantity square plus y minus 2 quantity square. So f4 here, so that means we need to add 8 on the right hand side. So 8. And then the center is right at 2, 2. And then the radius would be considered 2 root 2. Okay, so the center, so 2, 2, so 2 units to the right, and then up 2, so it's all the way over here. And then the radius, 2 root 2, so 2 root 2 units to the top. And then 2 root 2 units to the left. 2 root 2 unit to the right, and 2 root 2 unit down to the bottom, and simply just connect them. So that's just another equation of a circle. Okay. And also you can always check the graph on the calculator. So this one, 4 sine theta, 4 cosine theta. Okay, so using the TI. So once you turn it on, so make sure that you need to switch the mole from degree to radian. So mine is already in radian. And also for the function type, so you want to use the polar form instead of using the regular function, xy coordinate. So that's a polar r theta. Highlight it, enter, and then go back to y equal. So type in the function. So the function that we have right here, it's what? 4 sine theta plus 4 cosine theta. So 4 sine theta plus 4 cosine theta. Again, zoom, standard. Here you go. It's a circle. So this one looks like ellipse, but once you zoom it in, it's a circle. Okay? And now the next type of a conic, the polar equation. So we do have a line graph. Okay, so let's go back to that one, the template. So for this third type, so we do have a line graph. So we do have a theta equals pi over 12, or r equals 2 secant theta. So for those you might be wondering, what do we do with this type of polar graph? Polar functions. Okay, so I just want to pull it out right here. Okay, so for the line graph, so we do know that, well, why is the line? Because that theta, so again, theta is written as inverse of tangent of y over x. So in other words, this one, tangent of theta, it's considered y over x. So tangent of pi over 12, so that equals y over x. So again, pi over 12, it's a non-special radian, but we can always use the half angle identity. So the half angle identity will give you that the trig ratio. So that one, it's considered pi over 6 divided by 2. So we do know that half angle identity of tangent, it's considered 1 minus cosine of theta over sine theta. So theta here, it's pi over 6. So this one is written as 1 minus cosine of pi over 6 over sine of pi over 6. So we write it, so it's 1 minus cosine of pi over 6, cosine of 30 degree, root 3 over 2. So sine of pi over 6, sine of 30, 1 half. Multiplied by 2 top and the bottom, so we do have 2 minus root 3 over 1. Okay, so it's 2 minus root 3. Again, multiplied by 2, rationalizing. So we got 2 minus root 3, so that equals y over x. And then this one just need to cross multiply. So for this one, it's considered y equals 2 minus root 3 times x. So find out what that is on the calculator. So 2 minus root 3, so what is that about? So that one is about like point something. Okay, let's find out what that is, the slope. So 2 minus second radical is 3. It's about 0.2679, so round it up to 2 decimal places, about 0.27. So that one is just y equals 0.27 x. Okay, so started at the pole or the origin, so 0.27. So that one is greater than 0.25, so it's greater than 1/4, a little bit slightly higher than 1/4. So just using that estimation. So 1 unit up and then 4 unit to the right, a little bit over. So somewhere over there. And then basically just connect them. Or it could be 1 unit down, 4 unit slightly a little bit more to the left. Okay, connect the dots. Okay, like that. So pi over 12. And then for those you might be wondering, the other one is like pi over, this one here is like pi over 15. Okay? So pi over 12. And then the other one here, so r equals 2 secant theta. So again, rewrite it. So secant is considered cosine, 1 over cosine of theta. And then this one, what we can do, cross multiply. So r cosine theta equals 2. So that means x equals 2. So x equals 2, that's just what? It's a vertical straight line here. So 2 units to the right, it's a vertical straight line. Okay, so check it out, theta, pi over 12. Okay, so this one, well, if you try to type it down in a calculator, the TI, it doesn't show that theta. So you need to convert it back to the rectangular form. And then this one, x equals 2, so r equals 2 secant theta. So let's check that one. So 2 over cosine of theta. Okay, zoom, standard. Here we go. Just a straight line. Okay, so that's pretty much the first half of the polar graph. Okay, so the second half, we'll talk about that next time. So next time, we'll talk about the cardioids. Okay, so you need to sketch that, the normal sine curve, cosine curve, with the transformation. And also plot the points on the polar coordinate system. And then the limicons with the inner loop. Okay, so we'll find out about this one. Okay, so thank you for watching the video today. So stay tuned. So the second half should be up there by tomorrow. Okay, see you guys next time. Have a great one.